Hello, algebra students. We're going to look, algebra students, at AM4, lesson 13, solving quadratics by completing the square. At this point, you should know how to complete the square for a given expression, how to find that magic number that gives x squared plus bx term, that magic number that will get it into a perfect square format. We'll review it a little bit, but I'm kind of counting on you to have done AM4 lesson 11 and 12 and be somewhat proficient in those skills. And we will solve three different levels of problems, difficulties of problems, by completing the square in this video lesson, and in addition to listing the steps for solving these completion of the square problems. Okay, let's move over to our magic, our drawing pad, and see where we go from here. Okay, so this is, again, we are AM4, lesson 13, solving quadratics by completing the square. And this is an algebra standard that you do need to know. So let's look at the steps. We'll just write them over here on the right side, and then we will be solving our problems on the left side. So let's look at the first thing that we're going to do. And let me just write down a problem. Let me just start by writing down a problem so you can be absorbing it. While we go. Now, this is an easier one. And in fact, this problem can be solved by factoring. But we're not going to solve it by factoring. We're going to solve it by completing the square, because it will yield easier results. And we will come to understand at the end of this lesson that we can always solve quadratics by completing the square, but factoring is limited to a certain set of quadratics equations, ones where we can use the discriminant to determine whether or not we can use whether or not we can use factoring. Whether or not, but in every case, we can always use completing the square, which is why this is more powerful as a general tool. So the first thing we're going to do is we're going to, and let me rewrite this just a little bit differently to make it just a little bit harder, and it'll give us the ability to use our first step without skipping it. So our first step says we're going to get all of our x terms onto left and constant terms on the right. That's the first thing we're going to do. The second thing we're going to do is, if necessary, divide slash factor the x terms by coefficient of x squared term. So if the x squared term is not a 1, then we're going to divide the x squared and the x term by that coefficient of the x squared term. And so that's kind of part 1. And then part 2 is going to be, we're going to find the magic number to make left side be a perfect square. Three, we're going to add the magic number to both sides, to left side, and correct number to right side to balance equation. 4, we're going to factor left side to perfect square. And we're going to simplify the right side. In other words, the right side will be made into a single number. We'll see that in a second. And the fifth thing we do is we're going to solve. And that's kind of like part A. You know, we're going to solve for squared term. And then B, we're going to take square roots and create 2 equations to solve. Okay, so this is kind of a rough sketch of what we're going to do. My handwriting's not that great, but bear with me. So let's look at what we do. So we're going to do first things first. We're going to take our x terms, our variable terms, and we want those on one side of the equation, and we want the other thing on the other side of the equation. So let's get a strategy that puts this on the left, which it already is, and we'll get this one on the right. So the way that we're going to do that is we're just going to subtract 12 from both sides of our equation. So on the left, we get minus 12, and on the right, we get x squared plus 7x. Easy enough. That was step 1. Step number 2 is, if necessary, we're going to divide or factor the x terms by the coefficient of x squared term. Well, the x squared term here has a coefficient of 1, so we don't need to do this part. We don't need to do that part on this problem here. So let's just kind of erase that. So we have x squared plus 7x is negative 12. So now we need to find the magic number that makes the left side a perfect square. Well, that number is always, you know, it's a half of b. So a half of b, which in this case is 7, and then we're going to square it. The middle number, the second number squared divided by 2 squared. So in this case, we get 7 over 2 squared, which is equal to 49 over 4. So we say x squared plus 7x equals negative 12. And to both sides, we need to add this term. And this is step 3. This is 2 and 3. We're going to add 49 fourths to both sides. This is an equation. I can add 49 fourths to both sides. And you say, well, why am I doing that? Well, I'm doing it so that I can make this left side a perfect square. And the idea is to kind of take these 2 x terms and combine them into one x term. And watch, because if we take the square root, or sorry, if we factor this, we can factor this into x plus 7 over 2 squared. And notice that after we have created this magic number that happens to be b over 2 squared, you can either take this number is either the square root of this one, which is 7/2, or it's half of b. Those numbers are the same. It will be the same in every case when you use this formula to create this last term. So we get x plus 7/2 squared, and that equals, on this side, we're going to have to combine. So let's see, that's negative. If you don't know how to do this, you need to go back to 7th grade math and work on these problems. I'm not going to teach it to you. Negative 48 over 4 plus 49 over 4. Oh, this is cool. That equals 1/4. Okay? 1/4. So see what I did? This whole idea of 2 and 3 is taking this x squared term and this x term, and I kind of turn it into just an x term. And you can see how this, if you do these enough, you see how this leads to simplicity. So let me just write this out one more time, and I'll write it in a different color. What we have. So we now are down to x plus 7 over 2 squared equals 1/4. Now what we do is this was step 4. We factored this term from up above. Now we factor the left side to be a perfect square, and we simplified the right side. Then we have to take. Now we're going to solve. So we solve for this square term, which we're there. We won't always be there. You'll see on problem number 2 and 3, we won't be there necessarily at this point. But we are there right now. So now we can just take the square root of both sides. And when we do that, we create 2 equations. We have x plus 7 over 2 equals the square root of 1/4, and x plus 7 over 2 equals negative the square root of 1/4. And that's because, so first of all, the square root of x plus 7/2 squared square root is just x plus 7/2. If you square a term and then take the square root of that, you get the term. Same thing as if I said the square root of x squared. That is x squared square root is just, takes you back to x. You square the number and then you undo it. So that's where we're at. Okay, so now the next step is to solve these 2 equations. Well, let's look and see if we can find the square root of 1/4. Well, the square root of 1/4, and this goes all the way back to, I think, AM6, or at the end of 8th grade, the square root of a fraction is the same thing as the square root of the numerator over the square root of the denominator, and that's starting to look nice. Square root of 1 is 1. The square root of 4 is 2, and my dog agrees. So we get x plus 7/2 equals 1/2, and x plus 7 over 2 equals negative 1/2. So to solve for x, we subtract 7/2 from both sides, and we get x equals negative 6/2, or negative 3. And here we get minus 7/2. X equals negative 8/2, which equals negative 4. So x equals negative 4, comma, negative 3. And that deserves a happy cat. Happy Cat's going to come down here and look at this answer and go all the way back up here. And he's going to say, meow, I could have done this by saying, well, x plus 3 times x plus 4 equals 0. And then used with the big X. And then I could say, well, x is negative 4, comma, negative 3. Meow, why did I have to do all that? Well, you'll see in a second that not everything. If you can factor, factoring is a great way to go, but you cannot always factor. Okay, so let's go back. Let's try a couple more problems. I'm just going to take some time to erase all of this stuff, and we're going to try this same strategy with 2 more problems that are a little bit more complicated. And we're going to, let's see, 2x squared minus 5x minus 12. Okay, let me just erase. We'll just erase the rest of it like this. Okay, so our problem is 2x squared minus 5x minus 12. So the step 1 is to and that equals 0. So we're going to coalesce our x squared terms on our x terms on one side. and our other terms on the other. We had to add 12, right, to both sides. So that's step one. Step two, if necessary, divide or factor the x terms by the coefficient of x squared term. Well, here I don't have an x squared, or my x squared term has a coefficient, so I need to factor out this 2. So I need something that looks like this. 2 times x squared minus something times x. So if I divide this by 2 and I divide this by 2, I get minus 5 halves x. And that equals 12. Right? So this is legit. I can factor this and I can say, well, if I go backwards, I would get 2x squared. And if I multiply 2 times negative 5 halves, I get minus 5x. And so that is equal to what I started with. So we're good. I'd like to check that step, and I encourage you to do so too. Now we need to find the magic number that makes this a perfect square. And that is the middle thing, negative 5 halves over 2, and then square it. So negative 5 halves over 2 is negative 5 fourths. And if you have a struggle with that, that's negative 5 halves divided by 2 is equal to negative 5 halves times 1/2 equals negative 5 fourths. Okay. Erase that, and we have to square it. And that's 25/16. So 2 times x squared minus 5 halves plus 25/16 equals 12 plus what? Well, 2, on this side, I added 25/16 times 2. So that's 2 times 25/16, cross, cross, 8, equals 25 over 8. So we get plus 25 over 8. So that's step 3. Step 4, we're going to factor the left side. Well, that's easy. That's 2 times x minus, well, it's this 5 fourths number, x minus 5 fourths. That should be an x. It's always going to be this number. Whoops, that's not an x. Yes. So this number here is always half of this number. Right? Then this number is half of this number, or it's the square root of this number. So it's you can just always look to this number. After you took this half number, this number here is going to carry down into here. And so that equals, well, we got 96 over 8. Hopefully you know how to convert that, plus 25 over 8. So that equals 121 over 8. On this side, I have 2 times x minus 5 fourths squared. Okay, so that was step number 5 is we're going to solve. So now we need to solve for the square term. So let me show you the square term. The square term is this term right here. And because it's not by itself yet, we have this 2 hanging out over here. We need to divide both sides by 2. And I can multiply, I can multiply this by 1/2 to divide it by 2. Same difference. So we get x minus 5 fourths squared equals 121 over 16. Now I have to turn this into 2 equations. So let's turn it into, put them here and here. The first one, if we take the square root, is x minus 5 fourths equals, the square root of this is the same thing as the square root of 121 over the square root of 16, which equals 11 over 4. Equals 11 fourths. Or x minus 5 fourths equals negative 11 fourths. Those are our two equations. So to solve for x, we're just going to add 5 fourths to both sides. So x equals 16 fourths, or x equals 4. Or we add 5 fourths to both sides, and we get equals negative 6 fourths, or x equals negative 3 halves. So x equals negative 3 halves, comma 4. I'm going to go double Happy Cat on this one just because it got a little bit more involved. Happy Cat comes in here and he checks it out and he says, whoa, we had to deal with this extra factoring piece. We had to deal with, man, some tricky fractions. Our answer had some fractions. We got Happy Cats all over the place. We successfully navigated the waters of completing this square. Now, the next thing we have to do, we're going to look at one more problem. And this problem here, we're going to not be able to use factoring to solve it. We could have actually used factoring on even this problem here. But this next one is not factorable. And I'm going to show you, we're going to walk through why you know that's true. And then we're going to use a number of tools that we've learned in other chapters to put a lot of good information together and solve a pretty involved mathematical problem. So hang with me on this one. So this is a half x squared equals negative 6x plus 7. Well, you're looking at this and you're saying, well, maybe I can solve this somehow by factoring. Well, the first thing I'm going to do, and this is totally legitimate, is you can just say, hey, I want to get rid of this fraction, so I'm going to multiply everything through by 2. So let's just multiply both sides of this equation by 2 and get rid of that fraction and say, well, we have x squared equals negative 12x plus 14, right? There's our distribution. Now I'm going to try and put this into a factorable format. And I'm going to say, well, x squared plus 12x minus 14 equals 0. Now I'm going to hold out some hope that this can be factored. Well, I have a tool called the discriminant. And that is b squared minus 4ac. And we're going to use this to see if I can factor this thing. Remember, if this is a perfect square, then I can factor. So let's look at this. So we have our a equals 1, our b equals 12, and our c equals negative 14. So let's go. 12 squared, that's our 12 squared, minus 4 times 1 times negative 14. That equals 144 plus 56. So that is equal to 200. Well, I know that 200 is not a perfect square. Not a perfect square. Why? Because 14 squared equals 196 and 15 squared is 225. So I know 200 is not a perfect square, so I have to solve this So I have to solve this by completing the square. There's another tool I can use called the quadratic formula, but we haven't learned that yet. And so we have to complete the square. So step one, x terms to left, constant term to right. Step number two, well, we've gotten rid of this fraction thing, so this actually works out nicely. We don't have to divide this thing or divide anything by by this coefficient of x squared. So we can just simply move into finding the magic number, which is 12 over 2 squared, which is equal to 6 squared, which is 36. So we're going to add, and that's step 2 and 3. We're going to say x squared plus 12x plus 36. And then we have to balance the right side by adding 36. Now we're going to factor the left side, and we're going to get our perfect square. X plus 6 squared equals 50. All right. Now we're into our solving mode. Well, we don't have to do, there's no coefficient out here, so we don't have to do any division. We can just simply take the square root of both sides and create two equations. First equation is x plus 6 equals root 50. And the second one is x plus 6 equals negative square root of 50. And I go, well, x equals negative 6 plus root 50 if I subtract 6 from both sides. And on this side, I get x equals negative 6 minus root 50. And I'm almost there, except for the fact that the square root of 50 is not simplified because I can pull out a perfect square. So if you remember your rules of factoring or rules of simplifying radicals, square root of 50 is 5 root 2. If you don't remember those, you have to review them. So because this unit depends on it. So here we get x equals negative 6 plus 5 root 2, and x equals negative 6 minus 5 root 2. Or that can also be written as x equals negative 6 plus or minus 5 root 2, for those of you who want to combine. And that is our lesson for today. Let's see here. Signing off.